Hello, thank you everyone for joining us today. I hope you're all safe and well. My name is Shobhan Deer. I'm the Vice President of Oxford Climate Society and a PhD student at Oxford University working to develop sustainable battery chemistries to support renewables. For those of you joining us for the first time tonight, I'm excited to introduce you to our Net Zero Climate School. This is a 5-part webinar series aimed at school strikers, university students, and anyone interested in tackling climate change and who wants to learn more about achieving net zero emissions. The idea from the series came from Miles Allen, who you'll see hopefully very active in the chat today. He is Professor of Geosystem Science and Head of the Climate Dynamics Group at Oxford University. Miles is also the Senior Member of Oxford Climate Society and will be speaking at our final event on Friday. This series is in collaboration with The Guardian and also the Climate Works Foundation and Oxford Climate Research Network. So for context, on June 27th, 2019, almost a year ago, the UK became the first major economy to end its contribution to climate change, to pass laws to end its contribution to climate change by 2050 by producing net zero emissions. For those who don't know, net zero emissions means the emissions produced subtract the emissions removed has to equal zero. Therefore, this can be done in 2 ways. Firstly, by reducing the emissions we actually produce. For example, moving to renewables over fossil fuels, eating less meat, cycling instead of driving. And the second way is by removing emissions that we actually are producing already. And this can be done using trees, for example, or through new carbon capture technologies. And you'll hear more about these in the rest of the series. So achieving net zero emissions will be one of the defining challenges of our time. This webinar series aims to empower Generation Net Zero with a deeper understanding of what net zero means and what it will take to achieve it for both the UK and the world. For those who saw today's BBC Radio 4 puzzle before the event began, asking how long do we actually have to reduce global carbon dioxide emissions to net zero, given we've reached 1.1 degrees of warming already, so how long will that take to reach 1.5? And the answer is 40 years. So we need to be net zero by 2060. So why 2050, you might ask, as the UK has agreed to and the IPCC is recommending. There are other drivers other than CO2, such as methane, which can easily add to global temperature increases over the next 20 to 30 years. So we actually need to get to net zero CO2 earlier, and there is a strong argument that countries such as the UK, which have benefited in the past from carbon intensive activities, should get to net zero before the global average. So just to say a brief bit about Oxford Climate Society, we are one of the largest societies run at Oxford University, aiming to develop the next generation of informed climate leaders. We run weekly events with world climate experts and education programs throughout the year, including our School of Climate Change, which is free and open to all. And the next one will be taking place next term, so we would encourage you to apply if you're interested. In addition, we run the world's largest student-led climate journal, Anthroposphere, and we're also working with Oxford University to develop net zero policies and incorporate climate change on the Oxford curriculum. I'm delighted to announce that Fiona Harvey, environment correspondent of The Guardian, will be moderating all our events this week. And Fiona is an award-winning environmental journalist at The Guardian. Prior to this, she worked for the Financial Times for more than a decade, and she's reported on every major environmental issue from as far afield as the Arctic all the way to the Amazon. And her range of interviews has included Al Gore and Tony Blair. There'll be an opportunity to ask questions directly to our speakers. So if you have any questions, please ask them in the YouTube chat box, which is on the right-hand side. So just type them in there along with your name and where you're from, and we'll try and get through as many as we can. So let's start off our Net Zero Homeschool with our second event of the series, Pathways to Net Zero. Fiona, over to you.
Thank you very much, and thank you for that kind introduction. And it's my pleasure to introduce our 2 speakers today. We'll be hearing from both of them in turn, and then after them, at that point, you will have the chance to put your questions. What we'll be hearing about is how we get to net zero. What are the kind of pathways to that? What are the things we need to do, because when the net zero target was enshrined in law in the UK almost a year ago, in many ways it raised as many questions as it answered. It answered the question of when we need to reduce emissions to net zero by, and as we've just heard in the puzzle, we need to do that by 2050, according to the law. But it didn't say anything about how we do that. And that's the question that really has become ever more urgent in the past year. So that's the question we'll be looking at in the first half of this session. And for that, I'm calling on Steve Smith. He's the project manager for greenhouse gas removal at the Smith School of Enterprise at Oxford University. His previous roles are of particular relevance to this question today, because he's going to talk about pathways to net zero for the UK. And Steve's earlier job was to work for the UK Department of Business, Energy and Industrial Strategy, looking at research programmes there linked to policy and informing policy. And he was also the lead scientist for the UK's Committee on Climate Change, which is the committee set up under the Climate Change Act to oversee, to advise government on what it needs to do to meet our climate change targets, now the net zero target. So I'm going to hand over to Steve and we'll hear from him, and after that we'll have a few questions and we'll go to the second half of the session after that. So Steve, take it away.
Thank you very much, Fiona. And hello, everybody. It's a pleasure to be speaking to you this evening. So as Fiona said, I'm going to talk to you a bit about UK Net Zero, what the UK's target actually is, what it means, and how we might go about achieving it. And first, I just wanted to start off by giving you a little bit of context of what the UK's greenhouse gas emissions look like, where they come from, and what the trends have been, just to show you the sort of the nature of the challenge. So I have a chart here which just shows UK emissions of carbon dioxide over recent decades. They've been around sort of 500, 600, heading up to 700 million tonnes of carbon dioxide emitted by the UK per year, reaching a peak around 1970. So they've been high for a long time. And of course, you'll all know that the UK was one of the first countries to industrialize. So we've been emitting a lot of carbon dioxide for a long time. But also they've been generally on a downwards trend since the 1970s. And certainly since 1990, which is an important year in climate policy. That's the baseline against which lots of targets are measured. It's when arguably the world really came together and first officially recognized that it needed to do something about climate change. So emissions have actually been declining. This is, I should say, territorial emissions. There are different ways of measuring UK greenhouse gas emissions, but this is the standard practice that's used by countries in reporting to the UN under climate negotiations. And this is what our climate targets are largely based on. And actually, 2020 is going to be an interesting year for emissions right across the world, not least the UK, because of course we've been on lockdown because of the coronavirus. In recent years, we were about 40% below 1990 levels. There's talk about us maybe being closer to a 50% reduction below 1990 levels this year. So we'll have to see what the stats are. But that's the general trend. And if you compare that to global emissions, which is the orange line I've plotted here, you'll see that we were a reasonable chunk of global emissions heading back in the 60s and before. We were nearly 10% of emissions at that stage, more if you go back further. But due to the combination of our declining territorial emissions and the rising global emissions elsewhere, we're now really about 1% of global emissions. So we're a pretty small fraction now. So where do these emissions actually come from? This is just a little infographic to show you broadly that there are a huge range of sources. The issue with tackling climate change is that greenhouse gas emissions come from all parts of society, all parts of the economy. But I can just pick off some of the big areas if I take you through this infographic. So this is looking at greenhouse gas emissions, so not just carbon dioxide, but the other greenhouse gases that we know warm the planet, methane, nitrous oxide, some artificial fluorinated gases. They totaled about 450 million tons in 2018, which is the last year for which we have final data. And you can see that the biggest sector of activity that emissions come from now is transport. That's cars, trucks, vans, ships, buses. Actually, what's not included in this is our share of international transport, which is probably another 10% on top of this. So if you take the size of the box that's for agriculture on that infographic, add on a box again, that will cover our contribution, our share of international aviation and shipping as well. So that, as you know, all those transport emissions come from burning oil in the form of petrol, diesel, aviation kerosene, shipping fuel, and that produces CO2. Then if we look at the energy supply system, this is essentially the emissions we get from coal and gas-fired power stations, but also the broader system that delivers these fossil fuels around. So we've got leakage of methane from gas pipes that deliver gas into homes and other areas that burn gas for fuel. We've got leakage of methane also from old coal mines in the UK. And we've also got emissions from refineries. So the big factories that take raw crude oil and convert it into the useful products, they emit CO2 as well. So that's what contributes to the 23% from energy supply. We've also got then emissions, a big chunk of emissions, about a third again from both business and residential emissions. This is largely when we burn oil and gas, mostly for heating. So when you have a gas boiler in your home, like I do, that emits CO2 and burning the gas for heating. Also, businesses in particular, they often have generators which provide electricity if the electricity supply goes down. So they often run off diesel, potentially oil or gas. We also have some emissions in there from things such as refrigerants. So refrigerators leak these fluorinated gases, these very potent artificial gases that are very effective coolants, but also greenhouse gases when they get into the environment. And we have some emissions as well from the medicines we use. But those are smaller chunks. Really, the biggest chunk of emissions in business and residential is again from fossil fuel combustion. If we go then to agriculture, it's a slightly different picture. It's mainly not fossil fuel combustion. It's actually the burping and the pooing from sheep and cows that produces methane. It's also when you apply excess fertilizer to the land, some of that fertilizer produces nitrous oxide emissions, also a greenhouse gas. And when you till the soil, if you work the soil intensively, you can get the organic carbon that's locked up in that soil emitted to the atmosphere. Then there's waste management. And again, you get methane from wastewater treatment facilities, also from landfill. So when we throw rubbish, particularly organic waste into landfill, that degrades over time and causes greenhouse gases. And then the little 2%, that's mainly from industries, but it's emissions from the chemical processes. So by actually manufacturing some things such as iron, steel, and cement, you generate carbon dioxide as part of the process. So that's largely where emissions come from. And to the right-hand side, you can see the trends and why UK emissions as a whole have come down. You'll see that really our progress so far has come from a subset of these activities. So we've got good news stories in energy supply. As you'll know, we've been building out a lot of renewables, particularly wind power, offshore wind power, and that's displaced coal and to some extent gas. Also, actually, our overall demand for electricity has gone down. So that's been part of the energy supply story. Also, we've cut emissions from landfill, and that's why waste management has come down. But also, the nature of industry in the UK has changed. So we manufacture a lot less physical stuff in the UK compared to what we did in 1990. So the iron, steel, cement emissions, those sorts of things have come down a long way. But that's arguably not as a result of direct climate policy. That's just been the way that we've shifted towards more of a service economy over time. So really that gives you a picture of how we've done so far. And if we're going to get down to net zero, we're going to have to see much more progress from these other sectors, such as how we heat our homes, how we do business and agriculture, in addition to continued progress in those sectors where emissions have already come down. So what is the net zero target in the UK? Well, the exact text is that UK emissions need to be at least 100% lower than the 1990 baseline. Why is that? Well, our legislation, the laws we have in the UK which dictate our climate action, come from an act that was passed in the year 2008, the Climate Change Act. And this came into being as an act right when I got my first job working for the Committee on Climate Change, and my first role was to help advise on what the number should be for the 2050 target. We came up with the 80% number, and this is over 10 years ago now. I can talk a bit about why it was 80% at the time, but it links very much to what Dave Frame was talking about yesterday about how our understanding of the science has evolved. We didn't have the Paris Agreement at that time. There are some really interesting elements about what's included and what's not included, and they're always worth looking for in net zero targets. So when you look at country emission targets or businesses that pledge to go to net zero, what are the things to look out for? Well, one of the things is that this 2050 target covers all greenhouse gases, not just carbon dioxide. So if you're covering all greenhouse gases, some of the ones, particularly from agriculture, are going to be very difficult to eliminate completely. So generally, it's more stretching in terms of what you can achieve if it's a greenhouse gas target rather than just a CO2 target. The 2050 target also includes our share of international flights and shipping. So again, that makes it harder because for aviation in particular, it's hard to see how you cut that down to zero. There is, though, some wiggle room in the Climate Change Act that the UK can use offsets, so it can purchase effort from elsewhere to help achieve its target. And that's a little bit controversial. That's a discussion point that gives it some wiggle room. That's another thing to look out for in the setting of net zero targets. The Climate Change Act has a couple of other things as well. So we updated this just over a year ago to 100%, as you know. So that's the basis of the net zero target. And that was something I was involved with when I worked in government. But there are things in addition to the long-term target. There's a system of 5-year limits on emissions called carbon budgets to get us there, so nearer term targets. And there's also this independent committee on climate change, expert advisors who are not politicians, they're disinterested advisors who help recommend these targets and monitor progress. So that's another important element to how we try and achieve this. So if I just wanted to tell you a little bit about the different things that policymakers have to trade off in thinking about these targets, because a lot of the stuff you will hear, you heard yesterday and we'll hear in following days will be about how do we achieve this. And I will talk about that a little bit as well, but there are a whole range of factors, a whole load of issues that policymakers and decision makers have to juggle in setting a target. So I'll sketch these out very quickly. If you imagine this axis where you've got you imagine UK emissions are way off the top of the slide at the moment, and we have to get them down to zero, that horizontal bar. So as you go down, you've got increasing ambition for 2050. You go past an 80% reduction, 90% reduction to net zero, or maybe even beyond and net negative emissions. What are the factors that come into play in making decisions about targets? Well, first of all, you've got what the science says. And that's both our understanding of warming and what we need to stay below, which of course is set by policymakers. But then given a certain target for what the world agrees we should stay below, the science tells you, well, what pathways are consistent with that? And of course, you just heard from the puzzle earlier today that we need to get to net zero CO2 emissions by 2050. But then there's this warming from additional emissions that is layered on top of that if we want to stay below 1.5 degrees. And these shaded regions, the orange shows you pathways compatible with staying well below 2 degrees. And the red region shows you broadly pathways that are compatible with staying close to 1.5 degrees. You've got a best estimate in the circle, but then quite a wide range for what global pathways are compatible with those temperature targets. So you've got the global picture. Then of course, a big question is, well, what does the UK do or any other country as part of that? And then you have to think about, well, fairness. And this is what Farhana spoke very clearly about yesterday, the fact that given the UK's relative wealth and also its historical responsibility, there's a good argument that while there are different opinions on exactly how you quantify fairness, it's pretty clear the UK should go further and faster than the global average. So that's a reason to go further than those global average pathways by 2050. Then you've got the politics of climate leadership or what others are doing. Everyone wants to be looking over their shoulders at other countries and kind of weighing themselves up. And this cuts two ways. So the UK government successive governments have had different views on this. I think we have a government at the moment, certainly in the run-up to hosting the international climate negotiations next year, that is very keen to be seen as a climate leader. So there's the question of what other countries are doing and how we stack up against those. There's also a risk, of course, that if you're a climate laggard, some people might say, well, that means you're not spending too much money, going too fast, too soon. But you might also see that there are opportunities for developing new industries here. So it might be an advantage to be a leader and not just a sacrifice. And that plays a little bit into the costs. So that might be what the global picture and fairness tells you, but then how feasible is it in the UK? These dots just show 3 different scenarios that the Committee on Climate Change produced in its advice on net zero. And you can see that basically that they've got different ranges, but they reckon that it is possible to get to net zero, if not a little bit further. But it does rely on some things which they would consider speculative at the moment. Certainly on the basis of the things that we think are pretty easy to achieve, if we just have a bit of steadfast commitment, we can get a lot of the way. We can get down to 77% maybe, but certainly not to net zero yet. So then they looked at, well, what's the cost of getting to net zero? And interestingly, what the estimates are showing now is that the costs of getting to net zero appear to be the same as the cost of what we thought getting to 80% by 2050 were when we set the 80% target about 10 years ago or just over. Now, you might think getting to net zero would be more expensive than that, but this is part of the good news story about how some of the costs of key technologies, especially renewables, have come down faster than expected. And so actually, we think that while there is an additional cost getting to net zero compared to 80%, the costs in aggregate have come down so that the overall cost of getting to net zero in the UK looks similar to the cost we thought of getting to 80% back in 2008. But another really, really key consideration for politicians, as well as these pathways, is it feasible, is how popular is it? What does the public think? Now, there are some surveys out there. There was a survey that was commissioned in particular, I'm aware of, in the run-up to net zero target, which suggested that actually there was broad-based support across the country for aiming for net zero emissions. So more people think that we should do it, certainly in the coming decades, than think we shouldn't do it. But there are some interesting aspects about public understanding. If you generally people have a low understanding of what net zero means and what it is, which is why I guess it's a good idea to have these sorts of homeschools. Also, a lot of people think that we should do it sooner rather than later. But again, coupled to that low understanding, perhaps possibly unsure of what that entails. But generally, there is a school of thought that we should be going sooner than 2050. That plays into fairness arguments. But all of this is what policymakers have to think of when they set the targets. And the targets we have are that the UK should go to net zero by 2050. And actually, there are targets for Scotland and Wales as well in law. So I'll try and speed through some of the actual actions that can get us there. I'm going to put them into 4 very broad buckets. One of them is use less, not useless, but use less. So as you've seen from where emissions come from, a lot of it is bound up with making stuff. And the fuel we combust to put together things in factories, to transport it around places. And so just cutting down on the amount of stuff that we have is a very effective way of cutting emissions. But also often we can find ways of getting the services we need, heating or lighting our homes, for instance, without completely going without, but using more efficient materials. So a great example of that is LED light bulbs, where 10 years ago, hardly anyone had an LED light bulb in their home. They use about 1/10 of the energy of more conventional light bulbs. Now, most light bulbs sold are LEDs, and that is a very effective way of cutting down on the energy embodied in the things that we want in life.
And can I just at that point, actually, I think it's appropriate to say, as you've mentioned the example of light bulbs, that wasn't a choice made by consumers. That was a government policy. In fact, it came from the EU that we would phase out the incandescent light bulbs and essentially force people to buy the more efficient type. Do you think that's significant?
Yes, so there are a whole mix of policies that can range from sort of financial incentives or just giving information people to regulations to actually phase things out or phase things in. And we have a whole mix of policies in the UK, some coming from the EU, some domestic legislation to achieve these things. And you're right, actually the case of light bulbs and appliances more generally, fridges, freezers, washing machines is quite a successful case study in regulating to phase out the less efficient things. The other second broad area is switching fuels, because as you know, fossil fuels, coal, oil and gas, make up a huge chunk of the climate problem. So we can switch to renewables, of course. In the transport sector, you can look at fuels based on biomass, waste products or crops. And some of those are already blended into conventional liquid fossil fuels at the moment. You can also look at courses at electrifying things. So electric cars is an area that's growing rapidly. Or you can run on alternative non-carbon fuels. And hydrogen is a very interesting one, which is being discussed a lot. And there are all sorts of questions about the infrastructure to use, but hydrogen has been used and is used to a small extent for transport already. This is a bus in London that I used to use to get to work, and it was at the time a hydrogen powered bus. And these fuels apply not only to transport, but also to heating our buildings. So you can move to renewable fuels or electrification, having an electric heat pump or electric resistive heating to heat home, or potentially in some cases, hydrogen powered heating as well. So that's switching fuels, but there's also products. There are some products for which carbon is embodied in the very manufacture or even the very fabric of them. So when you come to cement, iron and steel, but also the food we use, so meat intensive diets lead to more cows, more sheep, and emissions of methane and fertilizers as well. And also food miles means transporting some foods a very long distance. So by switching the products that we consume, moving to bio-related alternatives, to less red meat, then we can also reduce emissions that way. And then, so those are all ways of cutting emissions, using less, switching fuels, switching products. The other one, which will get talked about in the next couple of days with the speakers coming along, is to take back greenhouse gases and to suck them up out of the atmosphere. And for carbon dioxide, there are a range of different ways of doing that. Some we know and understand very well. So planting trees is a great way of soaking up carbon dioxide from the atmosphere. But also there are some more technological ideas that are out there, generally at a much earlier stage of development, which can capture CO2 from the atmosphere and remove it. And if you sequester it, put it in a geological reservoir somewhere, it could be a very permanent way of taking carbon dioxide out of the atmosphere. So there are different pathways for getting to net zero. And if you imagine that each of those four broad categories is a slider, you can sort of dial them up and down to different extents to balance out to get you to net zero. And as far as I'm aware, there are 4 studies, there may be more, that have looked at how the UK can get to net zero. There's the Committee on Climate Change's advice. There's also work by the Energy Systems Catapult, which is a publicly funded research group looking at energy systems, and they've done their Innovating to Net Zero report. There's work by others though. There's the Centre for Alternative Technology in Wales, which has done the Zero Carbon Britain report, and actually has been doing it for quite a few years. It's been ahead of the game in many ways, but a bit under the radar. They have a report suggesting we could get to net zero by 2030. There's also an Absolute Zero report, which was done by an academic consortium, I think led by Julian Allwood, who will be speaking on the final day with Miles. And so these are different ways of stacking up to get to net zero. And you can move these dials. I think it's fair to say that the Zero Carbon Britain and Absolute Zero reports focus less on the more technological removal options. And in order to get to zero, they therefore have to push further on the using less, being more efficient, potentially doing more on the switching products as well, and rearranging the way we use land to get to net zero. So they allow planting trees and doing more to soils to get more carbon into those, but not do the kind of engineered carbon capture and storage solutions. But I think a really important message is net zero is going to be really stretching. So there's not an awful lot of scope to pick and choose. All of these reports would go very heavy on improving efficiency and on switching fuels away from fossil fuels to alternatives. And just to underline the point that this is a big challenge, one way that I quickly like to think of these things is not in terms of the 30 years from 2020 to 2050, but how many opportunities do we have to replace products before we hit 2050? So if you think about the average gas boiler, sorry, this isn't a gas boiler, it's a radiator, but they last on average 10 to 15 years in a home. So you've probably got about 2.5 replacement cycles between now and 2050. If we want to be net zero in 2050, we have to have an alternative to gas boilers within that time frame. The average car these days lasts about 14 years. So you've got 2 and a bit replacement cycles then, maybe a bit less. The average plane lasts about 25 years. So you've really got 1 and a bit shots at replacing your aircraft by 2050. It's about the length of a gas power station. They last about 30 years. And it's actually less than the lifetime of an industrial blast furnace. So you think of iron and steel and making pottery and things like that. These require bits of kit which are generally run on fossil fuels, and they're going to last already. If you put a new one in now, it's expected to last beyond 2050. So we've either got to get all of these to zero, and not just that, but the supporting infrastructure. If you're moving to electric cars, you need to build out your electricity grid to support that as well by 2050. Or if you're not going to get them to net zero, you need to scale up removals to offset those. So to summarize, we have a target in the UK. It's in law, it's part of legislation to get to at least net zero UK emissions by 2050. And we can do it. There are pathways to achieve it. But there's a lot to do. And even by 2050, that means you need to get cracking on a lot of things. And in many ways, the most politically difficult things are not the setting of targets in 30 years' time, but it's what we do now to help achieve that. There is a school of thought, definitely, that 2050 is too late, given the UK's responsibility and capability for dealing with the problem. And also the UK is now only 1% of global emissions. So if we want to stay below 1.5 degrees or well below 2 degrees, it's pretty clear that the UK won't be able to do it alone and is not doing it alone. But it's a story that will involve many other countries, including India, which Ambuj will talk about now. So thank you, that's me done.
Thank you very much. That was wonderfully clear and concise. If I might just ask a quick question on the UK's emissions, what constitutes the UK's emissions, because obviously that's goes to the heart of this in some ways. We're not including the emissions of products and services that are built or generated abroad but consumed in the UK, are you? That's a bone of contention with some people. We heard yesterday from Farhana that the UK's emissions have declined to a large extent because a lot of the stuff that we use is manufactured abroad. So how would you address that?
Yeah, that's right. So what I showed was territorial emissions. So essentially what's emitted within our own borders, although the net zero target does include our share of international transport. So that's one chunk that goes beyond borders. But you're right, there's another way of measuring emissions, which is generally called consumption accounting or our broader carbon footprint. And that includes the balance of imports and exports. And the UK happens to have a very heavy balance towards imports. So actually we're one of the countries with the greatest mismatch between our consumption footprint and our territorial emissions. Our consumption footprint is quite a good deal higher. I can't remember the exact number, but something like 40% higher than our territorial emissions. There's a few things to say about that briefly, I guess. One is it's definitely worth being aware of that and monitoring that. And actually, DEFRA, another government department, does publish statistics on the UK's carbon footprint, so you can look those up. The way that all international agreements are set up is that countries measure their emissions and report them and set targets based on their territorial emissions. And in a perfect world, it wouldn't matter either way. Everyone could measure on a consumption basis or a territorial basis. As long as everyone was consistent, every country's emissions would add up to the global total. But of course, we're not in a perfect world. We have different countries going at different speeds. And then if you're importing a lot of emissions from a country which has much more lax climate policy, is much less ambitious, then you can end up with a situation where people have been worried, for instance, that industries might move. You get what's called carbon leakage. So that's one reason why having a global agreement is very important. You can minimize leakage. And I think one other difficulty with using consumption emissions is they're much harder to calculate. You have to have massive input-output tables of what's being produced where and how's that being traded internationally. So there's actually a lot more uncertainty on consumption emissions. But I think it's fair to say what we do know about consumption emissions from the UK going back to 1990, which is about as far back as we can push the estimates, is that yes, they are higher than UK territorial emissions. They were going up, but there's a really interesting kind of structural break that happened around the global financial crisis in 2008. And the UK's consumption emissions have been coming down as well as territorial emissions since 2008. So they're higher, and the percentage reduction compared to 1990 is consequently smaller, but they're coming down as well. So there's a lot more that can be said about the benefits or disbenefits of using one accounting approach or the other. I think it's probably important to be aware of both. And the reason why the UK emissions are set on a territorial basis is because that's the international standard process at the moment.
Thank you. Thank you very much for that. And we'll take questions from the audience for you later. But we're going to move on to the second half of today's homeschool, where we're going to find out about transformational change in an emerging economy. For that, we have Ambuj Sagar, who is the founding head of the School of Public Policy at the Indian Institute of Technology in Delhi, whose interests lie at the intersection of science, technology, and development. And some of his recent work has been on innovation policy for meeting sustainability and inclusivity challenges across many industries and areas of policy. He's also been an advisor to various Indian government ministries and agencies and multilateral agencies as well. So if we could draw on your expertise now, Ambuj, to find out what transformational change means in an emerging economy, that would be great.
Thank you very much. Let me bring my slides up. And it's a pleasure to be here. That was an absolutely fascinating talk by Steve. And I'm going to give a somewhat different perspective, I guess, and naturally, since I'm giving a perspective from India. And I'm going to talk about our low carbon transition, but I'm also going to put it in the context of the major development challenges that we face in this country. And I'm going to talk about how it kind of complicates how we think about the climate challenge and how, in a sense, it influences the kind of the pathway, the transition pathway that we would take in India. I'm very briefly going to talk about India's targets, and India does not as yet have a 2050 target, but in the Paris Agreement, India did put out a fairly ambitious targets, especially for a developing country, and the two main components were the reduction of the emissions intensity of our gross domestic product, that is effectively saying that our carbon emissions per unit economic activity would go down by about a third. And more importantly, we said that we would greatly increase the share of fossil-based electric power, particularly renewables, of which solar really was, as you can see from the screen, was really the big contributor. But all of this comes in the backdrop of major energy challenges that the country faces. It needs to greatly expand its energy supplies because currently it's using very little energy, and energy is very much linked to a lot of services that we find very important for human well-being, going all the way from space conditioning to lighting to communication, to transport, and so on. And so in some sense, improving well-being almost necessarily requires greater access to energy services. And while countries have begun to, in a sense, decouple the provision of this energy services and energy use, really, it still is not fully decoupled. So in some sense, India is going to, as it tries to improve the well-being of its people, going to increase the energy usage in the country. But also, since it's a poor country, you also have to think about energy access, making sure that energy is available to the poor and also therefore affordable. So even in the case of energy, our question is not just a climate challenge, but also taking care of these kind of development challenges. And on top of that, there are other pressing developmental challenges going all the way from trying to improve health, improving nutrition, enhance the economic development in the country, create jobs and all of that, all of which are extraordinarily urgent, especially given where India is in the kind of economic ladder as of now. I'm just going to put up a few slides that kind of show some trends in some key indicators relating to climate and energy. And I'm going to start with carbon dioxide emissions per capita for a few major countries: India, the UK, China, and the United States. India and the UK, obviously, because we're talking about these two countries in this session. And China and United States are the two other biggies. So I just thought I'd put up a kind of a slide that showed the trends in per capita carbon dioxide emissions, just to give people a feel for how different countries have been changing their pathways in the last 30 odd years. And as you can see, India has always had fairly low per capita emissions. We're up to just about 2.5 tons per capita, which is still about less than half the world average. And United Kingdom, actually, you can see, has done fairly well in reducing its carbon emissions per capita. United States also has reduced its emissions, but is extraordinarily high. And China has been actually increasing its emissions quite a bit in the past few decades. Here's a graph that shows cumulative carbon emissions. And I'm saying cumulative emissions because in some senses, since carbon dioxide accumulates in the atmosphere, cumulative emissions are a measure of that country's contribution to climate change, the accumulated emissions from that country. And again, you see that the trends are somewhat similar than the previous, although not completely similar, but similar in that India has been rising a little bit, but is still much more below the other countries. And of course, since this is cumulative, even though the United States has been reducing its emissions, the total is going up, and China, of course, again, is rising very, very quickly. And the United Kingdom actually has been fairly flat in terms of its responsibility to climate change. The next slide I want to put up is per capita power consumption, electric power consumption by countries. And the reason we focus on that in many conversations is because I talked about energy consumption earlier. Electricity consumption happens to be an absolutely key measure of contributing to well-being because it's a clean energy carrier and a very versatile energy carrier. And therefore, it very much underpins the range of the energy services that I talked about earlier, whether it's lighting, space conditioning, telecommunication, or actually a lot of industrial activity and all of that. So per capita electricity consumption really is seen as a measure of how that country is doing in many ways on many human development dimensions. And India is actually, while we've been again increasing our per capita electricity consumption, this graph shows in very stark terms that we are far lower than most other countries, certainly much lower than the richer countries, but even lower than China, and also actually the global average. That doesn't mean that we necessarily have to increase electricity consumption to the levels of these other countries. By doing things more efficiently, and Steve talked about that, we could actually provide the same energy services. That example of moving from fluorescent bulbs to LEDs is a perfect example, how you can use less electric power and still get the same level of lighting. But still, you still, again, given the low level of electric consumption, it just, again, throws in sharp relief the long road India still needs to go in making sure that this clean source of power and other energy sources are actually available for our citizenry. This slide shows how we're doing in terms of economic activity. I talked about earlier, I talked about the carbon intensity of the GDP. Here I put up the energy intensity, that is how much energy you use to produce $1, in this case, $1 of economic output. And again, you're seeing the whole world is becoming much more efficient in terms of how it's using energy in order to drive their economies. China, of course, had a very, very inefficient energy economy a few decades ago and has done a remarkable job in reducing its energy intensity, still much above the global average. India is around the global average. Everybody's reducing, and the UK is actually below the global average and also reducing. So this, in some sense, gives a kind of a backdrop on which, very broadly, under which India has to be thinking about making its decisions in the climate arena, and especially thinking about its transition to things like renewables and also meeting its other development needs. I'm going to put up one last slide here, one last data slide, which shows on the x-axis shows the gross domestic product per capita in US dollars, and on the y-axis it shows the renewable generation capacity of the country as a fraction of the total installed power generation capacity of the country. And as you can see, again, those 4 countries, India is about 20%. So India has basically been ramping up its renewable solar and, by the way, when I'm saying renewables here, I'm really focusing on solar and wind, modern renewables. I'm not talking about hydropower and biomass. India is been very aggressively adding capacity of these solar and wind, and has reached about 20% of its total installed capacity is now renewables. China has been even more aggressive, just over 20%. UK is exceptional, over a third, and the US is about 15%. The point I want to kind of highlight here is that while we're talking about on the y-axis the renewable generation capacity, the x-axis really represents the kind of the wealth of the country. And India is just, as a very poor country, its per capita GDP is about $2,000. China is about 10,000, UK is about 40,000, and US is about $65,000. So you see a remarkable spread in per capita income, and yet India is actually really being quite aggressive in embarking on its low carbon transition and moving away from fossil fuels and adding more and more renewables. Actually quite remarkable. But I want to talk about some of the complexities of this transition now. I'm going to take 2 examples here. The first example is the example of solar power, which I said I was just making the case that India has done very well. We had actually said that we would like to reach 100 gigawatts of installed capacity by 2022. The Prime Minister actually last year announced at the UN that India would like to go even well beyond that. And as a result, India has been adding installed capacity very, very aggressively. We are up to almost over 35 gigawatts of installed capacity, and we've done this in a very short time. But what that means is the focus really has been a very strong and single-minded devotion to increasing our solar installed capacity. But what that also means is the focus is on projects that actually a lot of capacity, that basically are utility scale projects. And here on the left-hand side, you see this photograph of a large solar farm, which basically it's exactly the kind of stuff you want to do if you want to add a lot of capacity in a short time, which India has actually been fairly good at doing. But on the other hand, solar power, being decentralized, also offers the option for enhancing energy access. One could have imagined a somewhat different pathway where India could have been very aggressively focused on using solar power to improve energy services in rural communities and especially remote communities. We've done some of that, but of our total capacity addition, off-grid addition in rural areas has been less than about 1 gigawatt out of the total of 35 that I mentioned. So effectively, what we are seeing is that a desire to greatly increase our renewables capacity and therefore contribute to global climate mitigation has caused a kind of lesser attention in increasing energy access. India could very well also have, and actually had wanted very much as one of its policy objectives, as it increases installed capacity, is to also build a solar industry. But again, given the short time frame in which we needed to build capacity and the longer time frames in which you actually have to develop industries, we basically ended up, again, not paying as much attention to industrial development. We have built solar manufacturing capacity, but not as much, for example, as China, which took a somewhat different approach in first focusing on building its industries and then doing its solar deployment. So in other words, what I want to just put out here is that in the end, one has to think about climate objectives in relationship to other development objectives. And the choices one makes in implementing climate objectives may actually sometimes have implications for other development objectives. And this kind of trade-off and synergies are exactly the kind of complex challenges that a country like India has to engage with. I'm going to give a second example here, which is the example of clean household energy. A problem not just in India, but in many parts of the world. There are actually almost 3 billion people worldwide that depend on not clean household energy, mainly biomass, as a way to do cooking in their household or do space heating. Well, it turns out that the burning of biomass, which is actually a fairly dirty fuel to burn, releases all kinds of pollutants that have significant health impacts on people. In fact, the estimates are that exposure to household air pollution from burning of biomass and other dirty fuels in households may lead to as much as 3.8 million excess deaths a year. So a huge, huge impact. Well, for many years, there's been a focus in the climate arena towards clean cook stoves. And we have an example here, a photograph of what is called a clean cook stove, which means that it burns biomass cleaner than the traditional three-pot, the stone, almost primitive stone stove that's used in many parts of the world. Well, this clean cook stove actually burns biomass much cleaner and therefore reduces. It turns out that the burning of biomass also has some climate implications, and therefore this reduces the climate implications from biomass cook stoves, traditional biomass cook stoves, but the pollution levels are not low enough to protect the human health to the extent we would like, to avoid all the health damages that I talked about, those millions of excess deaths and all kinds of other illnesses, morbidities that it causes. Well, the other alternative that, for example, India has engaged in quite aggressively is use of cooking gas. In this case, that cylinder that you see in the background of that woman on the lower right-hand side is a liquid petroleum gas cylinder that is hooked up to a LPG stove, which is a different way of providing cooking energy to households. Much, much cleaner. Actually, it's the gold standard for cooking energy in households. But the problem is that LPG is a fossil fuel. Therefore, by definition, it actually has a climate impact. So here, India has actually made a choice to go down a pathway where it has actually focused on health impacts, even though the burning of these LPG fuels, fossil fuels, is going to lead to some climate impact. I should clarify again that the burning of dirty biomass also has climate impacts. But that being said, moving to this LPG basically means that we are moving down a pathway where we have given primacy to the development objective of improving health to a climate objective. So in a sense, it's a kind of a different pathway we have taken. And I wanted to again give this as a different example of the kind of the complex challenges and the decisions that countries have to make in trying to figure out how quickly they go down and what particular pathway they go down in terms of this low carbon transition. India, of course, is a very long way from net zero. I think we are still increasing emissions. Our goal is to actually eventually bend the curve and then maybe down the line go to net zero quite some years from now. But even in this pathway of how to reduce our emissions, we have to actually think about all of these different kinds of challenges at the same time. So I'll just end with saying that, repeating that point, that while we made significant achievements in this low carbon transition, and actually really it is a kind of a transformational transition, very, very significant additions of renewable energy and actually improvements in energy efficiency. But at the same time, there are issues regarding the addressing of developmental challenges and opportunities and how to actually think about synergies and trade-offs. The key for a country like India, and all developing countries, I would say, is really to address these climate challenges while taking into account the development agenda. And the development agenda and the developmental concerns really vary from country to country. This in turn requires a balance between the pace of climate action and in fact the kind of the nature of climate action that countries undertake, and the need to plan to engage with the developmental dimensions of this transition. I mean, any step we take, we need to think about how do you also get the maximum development benefits possible. And when I say capacity, I really mean, by capacity, I really mean human, institutional, financial, and various forms of capacity that often are a constraint, both in moving faster on climate action or the kind of the planning needed to engage with the development dimensions. And I'll just end by saying, actually, I think this is an area where international cooperation will play a very, very important role, both in building capacity, sharing effective practices, in thinking about how resources can be actually brought to bear, global resources can be brought to bear on the low carbon transition for countries such as India. So in sum, a long way to go for India. India has already started moving down this pathway of its low carbon transition. But as it does that, it has to actually think about how to balance it with its developmental challenges, and working with global partners actually can very much help us on that. Thank you.
Thank you very much. And looking at this issue of development and reducing carbon, what's India doing in terms of building new coal-fired power plants?
Okay, so in terms of building new coal-fired power plants, I think this is kind of actually, it's different people have different views on this. While the government is not stopping building of coal-fired power plants, partly for the reason that I talked about, the fact that for us, coal really is a major energy resource. In fact, for us, it's other than solar, it's really, we have some wind resources for sure, but solar and coal are really our two big energy resources. And as we think about what I talked about, need to expand our energy supplies, coal is something that cannot be really left off the agenda. But having said that, the remarkable thing is that the price of renewables has come down so drastically in the last few years that actually investment decisions in coal are going to become increasingly less desirable. Partly because solar is almost already now getting to be almost as cheap as coal, certainly in terms of generation, but when you think about other aspects of needing to think about storage and all of that, is still more expensive, but it's coming down very quickly. So we are reaching a point where actually it's not going to make actually financial sense to be investing in coal power. So in some sense, actually the market itself is going to make coal less and less desirable, especially as one thinks about the longer term perspectives relating to coal. I mean, Steve talked about the fact that coal power plants are 30 to 40 years time frame. And so I think people are cognizant of the fact that the decisions you make today are probably not going to be, problematic down the line. So I think the coal story in India is going to probably play out somewhat differently than what we've been thinking about in the past few years. That I think market forces are going to, driven by the renewables transition, are going to make coal really less and less attractive for India.
Would you be advising the Indian government to invest in new coal-fired power plants or not?
Actually, I would. So before building new coal-fired power plants, and they've already been doing that, I would actually be focusing on the efficiency of other of our power plants. But I think the question really depends on what our energy demand is going to look like, especially in relationship to the fact that this crisis is going to have a huge the COVID crisis is going to have a huge economic impact. You're going to, India's economic growth had already been slowing down even before this crisis. So in some senses, that answer is only in relationship to what the energy demand is looking like and what are the resources that are available for us to meet that demand. And if it turns out that the energy demand actually really starts picking up aggressively, and we are not able to use other resources, then I think coal would necessarily be the kind of the gap. But as I said, my personal view is that I think it's going to be some time before we really get to that question in any significant way.
So you're saying that India can and possibly will build new coal-fired power plants, even though the world is trying to move to net zero, and those power plants will be operating for 40 years.
Well, I think that's true. I think the point is, if the energy demand in India picks up and India needs to build those power plants, it should. But I think I want to put this in perspective, actually. I mean, I think your colleague made the point that the UK has, for example, been burning coal since 1800. And many of those emissions are still in the air. So in some senses, the question of who should be able to build, or if you're thinking about a kind of an ethical side of what's appropriate to do at a particular point, I mean, you have to put this in the context of where India is in the developmental ladder. And it is in that context that I think we have to think about it. As your colleague mentioned, we can't think about a one-size-fits-all kind of a thing. The reality is that, you know, when we are talking about the UK going to net zero by 2050, in some senses, the UK could say that we could provide greater headroom to India to increase its emissions and therefore improve its development by taking a more aggressive pathway to reducing emissions and going even below net zero. And the world could actually choose to do that. So I don't, you know, this, I think this question of, and a pathway for a country such as India, which actually is a very poor country, has a per capita GDP of $2,000, I think has to be seen in both a historical and a global context, and not individually. I'm not saying I'm not a proponent of burning coal, but I am a proponent of providing improved, greater development for India's citizens. And that's why, for example, the example I gave of household cooking, I'm very much a supporter of India, for example, using LPG to provide cooking energy for its poor, rather than going the you know, let's say a different pathway. I mean, of course, if there was a zero emission way to provide energy, that would obviously be the best, but that doesn't exist as of now. And I think that's the question that I think we have to really be thinking about.
Thank you. I'd like to bring you both in now for some questions from the audience. We've looked at some of the issues around the generation of greenhouse gas emissions from energy, as we've just been discussing, and from other sources, as we saw in Steve's presentation as well. But let's look for a moment at this issue of carbon sinks or carbon sequestration, basically absorbing carbon from the atmosphere and storing it, preferably permanently, so that it's not affecting the climate. There are opportunities for that. You've both touched on them, but I'd like to ask you first of all, Ambij, about India's opportunities, particularly its opportunities in agriculture for increasing its carbon sinks. Is that a good news story for the future?
I think absolutely. I think actually in the case of agriculture, improving agricultural practices in the correct fashion, I mean, moving towards sustainable agriculture, and again, we've been trying to do that in quite some ways, actually has benefits all around. It has benefits not just for climate, but it also has benefits in terms of resilience, if done right, in terms of, you know, a changing climate. It has possibly also, you know, resilience in terms of, you know, against pests and all of that. So absolutely, I think agricultural, improving agricultural practices is almost a no-brainer. the complexity that happens in a country such as India is that a lot of our agriculture is smallholder farmers. And therefore the question of improving the practices of smallholder farming to both improve the climate aspect of that agriculture and also the other sustainability aspects turns out to be just a complicated thing, because you're talking about small farmers who actually are very diverse in terms of what the soil types are, in terms of what the agroclimatic zones are, the kind of crops they grow. And so unfortunately, the problem with sustainable agriculture is that it actually is very knowledge intensive. And so it's one of these things that is obviously the right thing to do, but the implementation, especially in a country such as India, but I think actually globally, every country's been trying to move down this pathway and has had trouble. I think that's why it turns out to be a little bit more tricky than it sounds. It's almost like this, what the economists talk about, this $20 bill lying on the street. I mean, it's almost a no-brainer, but actually, when you really go to pick it up, you find that it's a little bit, it's not as easy as one thought it was.
Thank you very much. And I'll come to Steve now with the same question, not just about agriculture, in fact, in your case, Steve, but looking at how the UK could work to not just increase carbon sinks, but find ways of removing carbon dioxide from the air. Is that a goer?
Yes, it is. I was listening to Ambuj and smiling because I think all the issues he mentioned about agriculture in India probably apply in the UK as well. So there are lots of things that can be done to improve how we manage the soils, to plant more trees, and lots of people say that there are lots of co-benefits to doing this. There are lots of good reasons for doing it, but doing it in practice is tricky. So it's something we should continue to do. But there are issues of doing that, and then I think Natalie will talk about that a bit more later on in this series. There's a really interesting opportunity to do that in the UK. Strangely, because we're leaving the European Union, we're leaving their big framework for agriculture and environment, the Common Agricultural Policy, and we're going to set our own policy. And the government has been quite clear that it wants to give money to farmers more directly for the environmental goods that they deliver, including carbon. So it'll be really interesting to see how that evolves in the coming years. But yes, we do have an opportunity as well in terms of more of the engineered solutions, which involve largely carbon capture and storage. So the idea that you can take CO2, purify it, put it in a pipeline and bury it underground. And we're in a position to do that because we have a big offshore oil and gas industry in the North Sea. So we've depleted lots of oil and gas fields in the North Sea, and they look like they could be very suitable areas to actually put the CO2 back under the ground. So I'd say that the legislation of the net zero target has really brought removals to the fore, and is starting to force people to think a bit more about these as options. I mean, that's one of the main reasons I've come to Oxford University, to explore this as a research area, because I think this is a really interesting question at the frontier of climate policy and sort of technology and innovation. There are some people who are a little bit worried that talking about vast potential for removals is a bit of a moral hazard. It kind of allows people to think, well, we won't need to do emissions reduction because we can stuff it all back under the ground later. I don't think that way. I think however you do it, you have to have very strong emissions reductions, because the scale isn't there to do so much removals that you don't have to do emissions reductions. But I do think it's an area that that needs more thought and will be an exciting area of sort of research and policy development over the coming years.
Thank you. You mentioned policy development, and I'd like to just ask, we've got some questions coming in about public support for some of the measures, the path to net zero that we've been talking about in the UK and India. And I'd like to know what level of public support you think there is for policy measures like the ones you've been talking about. Steve, I'll talk to you first, and then I'll come to you in a bit.
So there's strong support for reducing emissions in general, and then there's also strong strong support, sorry, for renewables, for wind and solar power in the UK. So surveys, including the government's own survey, it does, I think, every year, consistently shows strong support that renewables are more popular now than gas and fossil fuel and other and nuclear power, for instance. I think we're in more anecdotally, I think we're seeing a lot of early adopters for electric cars being really keen on the benefits you get from an electric car. It's not only the improved air quality and the not having to go to petrol stations, but it's often the mechanics of the car is just simpler, and you don't have to change gears and things like that. So it's an outright better machine in some cases, but that's still to be seen whether that's really got mass appeal. I think there are some areas of getting to net zero which are going to be more controversial, and it's going to be interesting to see when people start to see what is involved in getting to net zero, how public opinion plays through. So you do have to start thinking seriously about how people's diets affect the environment, for instance. And that's something I think that particularly younger people in the UK are thinking more about. And we are seeing changing dietary habits, but the government has really been very keen not to really go there as a thing to regulate. They want to leave it down to choice. The other kind of harder areas are around how we use the land, what we do in some of our industries, our historic iron and steel industries, for instance, where some of the measures, and actually carbon capture and removal, so these kind of direct air capture machines, they're really quite expensive and someone's going to have to pay for them. So I think it'll be interesting when we get away from the simple renewable story into some of these other areas of industry and land to see how public opinion plays out.
Excellent. Thank you very much. And Ambit, if I could put the same question to you. What public support is there for, well, not quite moving to net zero, but reducing emissions somewhere on the path to net zero? What public support is there for that in India?
So, there's actually quite significant public support for I mean, climate. I mean, let me just say, I mean, if you think about, for example, the renewable targets that India has taken on in the Paris Agreement, I mean, that's very, for a developing country, as I showed on that slide, especially when you put it in relationship to our economic capabilities, it's a very aggressive target. And I think people in the country were very, very supportive of that. We've also actually, I didn't talk about that, but India has actually had a very, very aggressive program on energy efficiency in the last many years. In fact, it was kind of, just to give you an example, many of the energy efficiency programs that we have, the first one that we put in place was actually energy efficient appliances. And many of the appliance manufacturers were a little bit skeptical that there would be a market for high energy appliances. So we had a star labeling program. So manufacturers were skeptical that the consumers would actually buy 5-star labeled air conditioners and refrigerators. And so the program really started very tentatively. It turned out actually people were fairly positive about that, even though it doesn't really make, in a sense, if you do a hard financial calculation, the higher cost of the 5-star appliance probably doesn't save enough energy to make it really worthwhile, but people were actually quite keen on doing that. And it really, so that appliance program, the energy efficient appliance program, took off very well. India's actually had this very, if we talked about LEDs, India's got the second largest LED market in the world. We actually disseminated, I think, if I'm not mistaken, over 360 million LEDs. So actually I think there are many government policies that actually have been fairly successful, and the public is actually very, very accepting on that. I mean, of course, there are some areas such as transport where I think, we're still following the kind of the global thing about buying bigger cars and all of that. And I should say that, I think in many ways for any technology, public support in many ways will depend on the cost of the technology. And as costs come down, public support actually rises. And I think therefore it is really a part of the responsibility of the global community is to make sure that the cost of technology, whether we're talking about solar, great success, wind, electric vehicles and all of that start coming down. And as costs come down, actually you find, and this is, I mean, I study technological change, consumer attitudes are very much shaped by cost. And as costs come down, preferences change significantly. So people are already inclined towards addressing climate change, but I think one can find that that interest actually greatly accelerates as things become a little, as the economics becomes a little bit more favorable.
Thank you. And if I could go into a little bit more detail on one of the technologies that you're talking about, well, one of the areas that you're talking about, and where cost, I think, will be particularly sensitive. You brought it up earlier, the issue of cooking and clean cooking versus this kind of biomass cooking, which, as you said, is closely linked to air pollution, which kills people, essentially. When we're looking at clean forms of cooking, are there not better alternatives, low carbon alternatives, instead of using any form of fossil fuel?
There are, in principle, one could, and there are some examples of that. One could imagine a solar photovoltaic panel coupled with a storage system. So the thing with solar is it actually produces electricity only when the sun is on, right? So you can't depend on it for cooking by itself. So you need to have some kind of a storage device that actually then stores the energy. And you can actually couple it to these new devices called induction cookstoves, which basically are ways of electric cooking, but very, very efficient and very safe. And so this is, for example, could be a possibility where you combine 3 emerging technologies: induction cookstoves, storage batteries, high efficiency batteries, and solar panels, as a way to provide a system that allows for actually what you said, effectively almost zero carbon. I mean, nothing is zero carbon because the manufacturing takes causes emissions, but in terms of at least operation, it is pretty much zero carbon. Again, the problem here is cost, right? I mean, while solar panels have come down, batteries are still expensive, induction stoves are expensive. So in some senses, and it's something I'm actually writing about, if one can think about a program of not just R&D, but a kind of a technology innovation program to drive down the prices of this system, one could very well imagine the emergence of really effectively zero carbon alternative for household cooking that could really be a revolution for the poor. I mean, on LPG, I mean, you're right in that while LPG is very efficient, LPG is still expensive. It's a fossil fuel. And for poor people, that becomes, for the really poor, it becomes a problem because they can't afford it. And so even though they realize the benefits of that, they many times will actually go back to biomass if they can't afford the LPG. So LPG it cracks the health thing, but the cost still remains as an issue.
Thank you. Thank you very much for that. And looking at these 2 very different paths to lower emissions, what can we say about equity around the world? Because we've touched on this, but it does seem that there's vast differences. Well, clearly there are vast differences in GDP and in capacity between the developed and the developing world. But how do we ensure that we hit the scientific target of net zero, which has been set? Because we need to hit it if we want to stay within 2 degrees, which is roughly the limit of safety beyond which the climate could go into very dangerous zones. We need to meet those targets. How do we do that fairly?
Sure. So there are multiple ways to think about that, right? I mean, one is exactly what happened in solar, right? We actually, I mean, Germany really was the most aggressive country there that helped drive down the prices of solar by creating this enormous market. And that actually has started this almost a revolution in solar photovoltaics across the world, right? So the first thing is you actually, either by doing R&D or by doing the kind of thing that Germany is doing by creating a market and doing what's called learning by doing, which is the more you're building, the more you're learning how to build it faster and you get economies of scale, you can actually drive the prices down. So that's one way of actually driving the transformation, saying we actually will globally make concerted effort to make low carbon technological alternatives possible that drive out fossils out of the market. The second one actually is, I think what we talked about earlier, carbon dioxide removal. I mean, I'm not a real fan of that because I do think that moral hazard problem of if we think we can remove it from the air, we are less likely to stop emitting it because, you know, it's kind of natural human thing. But in the end, I think, and again, that is an area that we can aggressively move to. I mean, you know, we're talking about net zero. Actually, a lot of people are talking about negative emissions. We're actually, net zero may involve negative emission technologies also, but there's no reason for, if the world does go to net zero, that the rich countries go only to net zero. Rich countries could certainly go way negative, thereby providing headroom so that the world goes to net zero. So, and I think that's where the graph that I put up, the cumulative emissions, becomes really important because I think it's that really puts the equity question right in perspective. That we really have to think about this as a stock problem, not a flow problem. We can't say in today's world, different countries have different levels of emissions, and we want to think about that. One has to think about the accumulation, and therefore the rich countries that actually, at that point when they were emitting, they didn't know, but of course now for the last 30, 40 years we've known, but they've got the financial wherewithal to be able to actually go negative, right? It is some question of cost, but they have the money. It's also a question of political will. So I think there's actually a mix of different kinds of options in order to do that. And my view is, of course, developing countries have to also do this. I mean, it's actually in their own benefit to do that, and to do that in a way that can also maximize the development benefits. For example, if there's going to be green industry, for example, there's going to be huge solar photovoltaic industry or EV industry, of course, I want India to be a player in that market. And so in some senses, developing countries also benefit by engaging in climate action. I think the point is how, and I think that's somewhere we've really, I have to confess, fallen short as a global community, is how do we come together and cooperate in order to make sure that we are able to reach exactly the point you talked about, which is a scientific target, but in a way that takes into account all of these questions about responsibility and capacity and bring it all together so that we are able to do it in a way that does not actually lead to a conflict between climate and development, but one is actually able to move forward in both of those, which is actually necessary for everyone.
Thank you. And Steve, well, in terms of equity, should the UK be going beyond net zero as we're a big economy and have a lot of resources and capacity?
There's certainly that point that can be made. I think if you want to get to below zero, then at some point you have to go through zero. So setting a net zero target is potentially not the end point, but it's a stage post to something else. And there is always the debate about whether rich countries like the UK and with their historical responsibility should do more.
But do we have the capacity to do more? Let's forget responsibility for a moment.
Right, okay.
Just look at who's got the capacity to do this.
So yes, can we do it? Well, the kind of countries, I guess if you were looking for a kind of ideal country that could go net negative, go beyond zero, you'd be looking for one with a lot of geological storage capacity compared to the size of its emissions. Or you'd be looking for one with a lot of land that could plant a lot of trees or do that. Now, in the UK, we don't have a lot of land, but we do have a lot of geological storage, potentially in the North Sea. So if you had some kind of capture and transport infrastructure, which could scale up, and we're talking big scale, we're talking making one in, if by 2050, in 30 years, that's kind of the size of the current oil and gas industry in the UK, but doing the process in reverse, if you like, sticking the CO2 back underground. If you can do that, then perhaps if all goes well, costs come down, it turns out to be genuinely effective at removing CO2, and people and companies are happy with you doing that, then maybe you can go net negative. And if you've reduced all your emissions, so completely decarbonized electricity generation, buildings, transport. So there are a lot of ifs in there, but if you're willing to buy those ifs, I guess that the UK would be one of the countries in the world that you'd think might be able to go net negative because of its geological storage capacity. That's something which Stuart Hazeldine, who's going to speak later in the week, is a real expert in.
Thank you very much. Thank you. That's, I think, most of our questions from the audience covered there, answered in one form or another. So thank you very much to you, Steve, and thank you to Ambuj for those excellent presentations which we've heard and for answering our questions. Thank you very much. I'll hand you back to the Oxford Climate Society.
Thank you.
Thank you very much, Fiona, and that was a fantastically moderated event. And thank you so much, Steve and Ambuj, for such a clear and interesting discussion. That was brilliant. So if you would like to learn more and you've enjoyed today's event, please join us for our third event tomorrow, which is on nature and land in net zero, with Natalie Seddon and from the University of Oxford, speaking on biodiversity and nature-based climate solutions, some of which you've heard mentioned today. And then with Nora Beramuni, who works at the United Nations Food and Agriculture Organization, and she will be speaking on feeding a net zero world and perspectives from the global south. So again, touching on a lot of these important points on equity that have been brought up today. So thank you so much again, all of to both of our speakers and Fiona for delivering such a fantastic event, and I hope you all enjoyed it at home. Please do share with your friends and for schools. We want to just encourage as many people to learn about this as possible, and all our events will be put up on our YouTube immediately after they finish, so they can be shared for free anywhere and everywhere. So thank you once again, and hopefully we'll see you tomorrow. Good night. Speakers, you can stay on for 1 second actually, and